So far, we have learned how to solve one-step inequalities. This week, we are going to learn how to solve two-step inequalities. A two-step inequality is an inequality that contains two operations. To solve a two-step inequality, use inverse operations to undo each operation in reverse order of the order of operations. Now, if you remember, the order of operations was PEMDAS, but they want us to do the reverse order. The reverse order was SADMEP. So we are going to be using SADMEP to solve these two-step inequalities. This is just like solving two-step equations, except instead of an equal sign in the middle, you're going to put an inequality symbol. Let's look at example number 1. Solve 3x plus 4 is greater than or equal to 16. So we're going to follow the steps of SADMEP to solve this problem. There is no subtraction, but there is addition. The opposite of addition is subtraction, so we're going to subtract the 4 on both sides. So we're going to use SADMEP to solve this problem. The S is for subtraction, but we do not have any subtraction. The A stands for addition. We do have addition. So let's circle the addition. Circle plus 4. Now we need to take the inverse operation. Inverse means opposite. The opposite of plus 4 is minus 4. We're going to subtract 4 on both sides. 16 minus 4 equals 12. Bring down your 3x on the left side. Once again, since this is an inequality, we do not need an equal sign in the middle. We're just going to bring down the greater than or equal to symbol. The next letter in SADMEP is D, division. We do not have division. Next comes M. M stands for multiplication. We do have multiplication. 3x means 3 times x. In order to get rid of the multiplication, we need to do the inverse operation. Inverse means opposite. The opposite of multiplication is division. Divide both sides by 3. The 3's on the left side will cross out because they are the same number. Then you're going to divide 12 divided by 3, and that equals 4. Bring down your variable x and your inequality symbol. Here's our solution. X is greater than or equal to 4. Next, we need to graph the solution set on a number line. We are going to put a closed dot on 4. The reason why it's going to be closed is that it is greater than or equal to 4. So we need to make sure we include 4 in the answer. Our inequality symbol is pointing to the right, so we are going to shade all of the numbers to the right of 4 on the number line. So here's the graph that matches our solution. This is showing that x can be any number greater than or equal to 4. Let's look at example 2 next. Solve 5 plus 4x is less than 33. Graph the solution set on a number line. We're going to use SADMEP once again to solve this inequality. The S stands for subtraction. We do not have any subtraction. A stands for addition. We do have addition. The 5 is being added to 4x. Circle 5. We need to do the inverse operation on both sides. The opposite of add is subtract. So let's subtract 5 from both sides. 33 minus 5 equals 28. Bring down your 4x and your inequality symbol less than. Using SADMEP, the next letter would be D, division, but we do not have division. So let's move on to M, multiplication. We do have multiplication. 4x means 4 times x. In order to get rid of the multiplication, we need to do the opposite operation, which would be division. Divide both sides by 4. The 4's will cross out on your left side since they are the same number. Bring down your variable x. Next, we're going to do 28 divided by 4, which equals 7. Instead of putting an equal sign in the middle, we're going to continue using the inequality less than symbol. Now we need to graph the solution set on a number line. We are going to draw an open dot on 7. The reason why it's going to be an open dot is that because x is less than 7. So we need to include all of the numbers that are less than 7. It does not mean that 7 should be included in our answer. Then we're going to shade the numbers according to our inequality symbol. Since our less than symbol is pointing to the left, we are going to shade all of the numbers to the left. Here's our graph that matches our solution. The graph shows that x can be equal to any number as long as it is less than 7. Let's try working through the got it problem at the bottom. Letter A, solve 2x plus 8 is greater than 24. Graph the solution on the number line provided. We are going to use SADMAP to solve this inequality. We do not have subtraction, but we do have addition, so let's circle the addition. Then we need to do the opposite operation. The opposite of addition is subtraction. Subtract 8. (24 minus 8 equals 16. Bring down your 2x and bring down your inequality symbol in the middle. Now we need to solve 2x is greater than 16. So using SADMAP, D would come next, but we do not have division. So M stands for multiplication. We do have multiplication. This is showing 2 times x. We need to do the opposite of times in order to get our answer. The opposite of multiplication is division. Let's divide both sides by 2. The 2's on the left side will cross out since they are the same number. Bring down your variable x. Next, we're going to do 16 divided by 2. 16 divided by 2 equals 8. Instead of an equal sign in the middle, we are going to use our inequality symbol. Put a greater than sign in the middle. Here's our solution. X is greater than 8. Let's graph it on a number line. I always start with whatever number in the middle. So since our answer was 8, let's start with 8 in the middle. And then we can put 2 numbers to the right and 2 numbers to the left. Since x is greater than 8, we need to put an open circle on 8. It cannot be a closed circle because it does not include 8 in the solution. Then we are going to shade all of the numbers to the right of 8 because that matches our inequality symbol. Here's the graph that matches our solution. X is greater than 8. Looking at the graph, we see that x can be equal to any number as long as it is greater than 8. Let's try some more difficult examples. Number 3, solve 7 minus 2x is greater than 11. Graph the solution set on a number line. Once again, we are going to use SADMAP to solve. We don't have any subtraction, so we'll circle the addition. Circle 7. The opposite of a positive 7 is a negative 7, so we're going to subtract 7 from both sides. Bring down your minus 2x on the left. 11 minus 7 equals 4. Instead of an equal sign in the middle, you're going to bring down your greater than symbol. Still using SADMEP, D would come next, but we do not have division. So let's look for the multiplication. We do have multiplication. This is showing -2 times x. In order to get rid of our multiplication, we need to do the opposite operation. The opposite of multiplication is division. Let's divide both sides by -2. The -2's on the left will cross out, so we're just left with x. 4 divided by -2 equals -2. Look what happened to the inequality symbol in the middle. We flipped it. This is an example of the flip-flop rule. The flip-flop rule means that when you multiply or divide by a negative number, you need to flip the inequality symbol. So here's our solution. X is less than -2. Let's graph this on a number line. We're going to put an open circle on -2. It has to be open because it is less than -2. It does not need to be included in the solution set. Then we're going to shade all the numbers to the left of -2. This matches our inequality symbol. The graph shows that x can be equal to any number as long as it is less than -2. You can check the solution by substituting a number less than -2 into the original inequality. Let's try using -3. So where the x was in the original inequality, we are going to substitute it and put -3 in there. -2 times -3 equals 6. And 7 plus 6 equals 13. That is true. So 13 is greater than 11. That is a true statement. So we know that we did our problem correctly. Let's look at number 4 next. Solve x over 2 minus 5 is less than -8. Graph the solution set on a number line. Once again, we're going to use SADMEP to solve. S stands for subtraction. We do have subtraction, so let's circle the subtraction. Circle -5. Next, we need to do the inverse operation. The inverse means opposite. The opposite of -5 is +5. Add 5 on both sides. Bring down your x over 2 on the left. -8 plus 5 equals -3. Instead of an equal sign in the middle, let's keep using that inequality symbol. Using SADMEP, we need to look for D, division. We do have division in this problem. This is showing x divided by 2. In order to get rid of division, we need to do the opposite operation. The opposite of division is multiplication. Multiply both sides by 2. The 2's on the left side will cross out since they are the same number. Bring down your variable x. Then we need to do -3 times 2. -3 times 2 equals -6. Bring down your inequality symbol. Here's your solution. X is less than -6. We need to graph it on a number line. We are going to put an open circle on -6 because it is less than. It is going to be an open circle because 6 does not need to be included in the solution set. We are going to shade all of the numbers to the left of -6 because that is included in the solution. The graph matches our answer. The graph shows that x can be equal to any number as long as it is less than -6. Let's work through the got it problems at the bottom. Solve each inequality. Graph the solution set on the number line. We're going to use SADMEP to solve these problems. So the S in SADMAP stands for subtraction. We do not have subtraction. The A in SADMAP stands for addition. We do have addition. Let's circle the addition. The opposite of addition is subtraction. So let's subtract 9. 5 minus 9 equals -4. Bring down your x over 2. Instead of an equal sign in the middle, we're going to put our inequality symbol greater than or equal to. The next letter in SADMAP is D, division. We do have division. This is showing x divided by 2. In order to get rid of division, we need to do the opposite operation. The opposite of division is multiplication. We're going to multiply both sides times 2. The 2's on the left side will cross out since they are the same number. Bring down your variable x. -4 times 2 equals -8. Bring down your inequality symbol, greater than or equal to. Here is the solution. X is greater than or equal to -8. Let's graph this on a number line. So since the answer is -8, we're going to start with -8 in the middle of our number line. We're going to put 2 numbers to the right and 2 numbers to the left. Now, since these are negative numbers, when you go to the right, the numbers get smaller. When you go to the left, the numbers get bigger. This is only the case for negative numbers. So to graph x is greater than or equal to -8 on the number line, we're going to put a closed circle on -8. The reason why it needs to be closed is because -8 is going to be included in the solution set. Then we need to shade all of the numbers to the right of -8. We need to shade the numbers to the right because we need to include all of the numbers that are greater than or equal to -8. This also matches our inequality symbol because they're both pointing to the right. Let's try letter C next. We're going to use SADMAP once again to solve this inequality. So first, let's circle the part that we're going to change. Let's circle the +8. The opposite of +8 is -8, so let's subtract 7 minus 8. 7 minus 8 equals -1. Bring down your -x over 3, and instead of an equal sign in the middle, we're going to bring down the less than or equal to inequality symbol. Using SADMAP, next we need to do the division part. We do have division. X is being divided by -3. To get rid of this, we are going to multiply both sides times -3. I'm going to put my -3's in parentheses just so we don't get confused with the negative symbols. -1 times -3 equals +3. Bring down your variable x. Now there's something very important that we need to do with this inequality symbol. We need to flip it and make it a greater than or equal to sign. This is an example of the flip-flop rule. The flip-flop rule is when you multiply or divide by a negative number, then you need to flip the inequality symbol. Since we multiplied by -3, we had to flip our inequality symbol. So this is the solution. X is greater than or equal to +3. Let's graph this on a number line. I always start with that number in the middle, so we'll put 3 in the middle. And we put 2 numbers to the right and 2 numbers to the left. Now notice how this is different from our graph above with all of the negative numbers. So to graph x is greater than or equal to 3 on the number line, we need to put a closed circle on 3. The reason why it's going to be a closed circle is because 3 needs to be included in our solution set. Next, we're going to shade all of the numbers to the right of 3. We need to shade the numbers to the right because it matches our inequality symbol. They both point to the right. The graph is showing that x can be equal to any number as long as it is greater than or equal to 3.